myself Mayur.
I'm Prakash.
I am Amrit Pieram.
And we are team Sapere Audit. So we'll come to the team later, but now coming to the main task for the problem solution.
So why phenol? So basically we have highlighted the word phenol, right? So when the Bangalore for past 17 hours have observed a lot of things. The drains are not proper compared to where I am. So wastewater is a major issue. The treatment of wastewater particularly. So rather than treating all the components of wastewater, we focus on a particular thing. That is phenol. Phenol is just a simple molecule with C6H5OH, but it's quite persistent. It likes to stay in nature. It doesn't want to go under biodegradation, and it wants to stay. Second thing, it's toxic. Even in very small amounts, that's less than 1 milligram per liter, it's known to show hormonal disruption in humans and also to accumulate in tissues and later cause issues. And third one, all the methods that we have till now to treat phenol are not efficient. So that's what we're doing.
So our proposal basically. So why? So coming to the why question. Firstly, why fungi? So why we chose fungi and not any other microorganism is because in case of bacteria, the problem is that the enzyme that is secreted can either be intracellular or extracellular. So with this, the process of obtaining the final product by downstream or upstream processing is a very tedious task. But in case of fungi, they are produced extracellularly, so it's easier for us to obtain. That's the reason we chose fungi. Secondly, why lacase? So we found out that a lot of the enzymes that help in bioremediation are oxidative reductases. So in that, one of the commonly used, currently used solution is not good, and because it uses hydrogen peroxide, H2O2. That's an additional chemical that we have to add for it to be a catalysis or initiator. So how lacase helps is it uses dissolved oxygen or the present oxygen in the surroundings. So the advantage is it is a natural source. Fungi is a natural source. It will be more cost effective. It's easier to culture. Fungi is very easier to culture, and the fungi species that we are using, that is Bisporus and Ostreus, all of them, those are the fungi that we eat. That's very simple and it's very easily grown. So that's the reason we use it. And why fungal based is because it's a greener alternative and it's a lower environmental impact.
Coming to the progress of what we did today, we did something very simple. It's just this. What we done? This. So basically, we have phenol compounds which are effluents, which are the problem-causing things. We just treat it with enzymes, and we get phenol which is non-toxic comparatively when we compare to phenol compound. And these enzymes are fungal enzymes that are obtained from a fungal mix. What we call it's basically A. Bisporus and P. Ostreus. Coming to the main thing, what is phenolphine? We have named our product or this process as phenolphine because it's phenolphine. Phenol is not fine.
So using the data tools that we have given, so what we did was we went through some protein data bank, NCBI and other databases, and we found out the structures. So that's not an issue. But what we found out, surprising to even us, was we don't trust AI. So AI told oxidized peroxide is better than lacase, but lacase proved to be better eventually. So the reason is it contains an imine. So iron is more heavy, whereas it limits flexibility. Whereas in lacase, it has copper ions and it has less disulfide bonds comparatively to oxidized peroxide. So it can accommodate more phenolic compounds. Not specific, it's like it can accommodate a broad range.
And coming to the main comparison, that why we chose this over anything else. So lacase has the raw material cost that we use is very lower, like it's of very low cost. That is a fungal biomass that we use. And scalability. Now we can grow fungi in different regions, like you can either use bioreactors or tissue culture or these kind of methods that are already available through biotechnology, and it's easily scalable. So like even if you make any change, scaling that from a pilot scale to an industrial scale is very easy in fungi. That's the reason we chose it. And third, overall cost production. So we saw that it's almost five times less than the current solution that's being used. So if you give 40,000 for the current method, we're using around 5,000 to produce the same amount of requirement. And hydrogen peroxide. So like I mentioned in the first point, hydrogen peroxide is an additive that we're using if you use HRP. Otherwise, hydrogen peroxide is not required and dissolved oxygen can directly be used by lacase.
So what is our future in this product look like? How does it look like? So basically, we have a lot of things to work on. This just ideation. We are just in ideation. This may or may not work. But the thing is, it will work. My bad. But the thing is, we need to look at what we need to optimize. Optimizing fungal strains. Now we have taken fungal strains to. Okay, we'll just finish. We have taken. Okay. Just
What do you want to conclude?
So. What is it?
So yeah, so the proof of concept we provided
No,
for
conclude.
yeah, everything that we provided is all from authorized scientific, and it has complete proof of concept for every process, and it is almost like 95 to 98% directly readily employable.
So what is your process of mistake, right? So you say the phenol comes from multiple industries, petrochemicals, multiple sources. So how is your process of introducing this into the ecosystem? How is that going to be?
So the current method that is there, whatever enzymes that are currently being used, they have like it takes a lot of energy and a lot of carbon emissions are taken for it to extract because a lot of downstream application is taking place. They're currently using industrial waste or agricultural waste like husk or straw, rice straw. So we are trying to curb that process by introducing our own formula because our last whatever we had given proposed solution to the previous segment, where we learned a lot about fungi and its capabilities. So what we are doing is to provide a cost-effective way and to create a circular economy. So and it's also greener alternative. So it will involve in the process where it will give a better alternative to all the existing solutions.
So the process looks like they go primary treatment, where they go, then you will so where does your process come in? Are you going to stick to this already existing process and you're going to use your stage, or are you going to go work with industries and then say collect their waste and then are you going to do something?
Can we leave?
How are you going to
Actually,
do
we are
that?
getting late
How
for
will you
this.
tackle it?
So first, we have the proof of concept, but if you have to put it into practical, then there are a lot of challenges. So first, we like to work with industries, like we may actually mention the roadmap, but we can explain. So we would like to first work with industries and find out how they are letting their agriculture waste out and what levels of treatment are taking place and where we can intervene in that. So because after one part of filtration, a lot of the coordinates will just get separated. So if we have to treat over it, we have to know in which segment actually our whatever we are trying to treat is going to be present, which is phenols. So we first intervene in those places, and once that is done, once we have an idea of how the treatment is taking place, we can optimize whatever species that we are there for different for other industries. They have particular phenol compounds, so this mild changes in the fungal strain will be sufficient enough to curb all the other problems.
As of now, what I would like to say is we would like to stick with one industrial company from where they are treating phenol at the moment. So we would like to work with them, understand where phenol, how they are degrading phenol or how they are treating phenol. We would like to be their point of view of how our solution can help them, and then probably we can even help the government in solving this.
Actually, sir, look at what company, what they do.
So current companies that are already doing this. So all the research papers that we have published, I mean, put up is all based on 2023-2024 current happening research. So this is an area that's ongoing research, and it has very promising results in the future.
You guys know for Ginkgo biology?
Ginkgo biology.
They use similar technology and they edit the curve cycle of the fungus algae yeast to produce even product of anything. Check it out.
Thanks.